Wow, is that a Vienna hot dog in series and parallel? Wow.
I know this is supposed to depict a wire, but no matter what, if you run a wire through Vienna sausage in either series or parallel, the Vienna hot, the Vienna sausage will still have resistance, whether you like it or not. So I'm gonna call this the Vienna sausage in the whole video. Anyways, I'll assume that you read the problem in the description, and sorry, my throat is hurting again, so we have to, so we have to find the total resistance in terms of R long, which is the resistance of the whole Vienna sausage, um, and N, which is how many pieces you cut the Vienna sausage into in order to make and then put them into parallel. So so we are given two hints. So there are three steps to solve this. Sorry. First, we have to find the resistance of the wire segments. So these are the wire segments. There's a lot more than three. There's an amount. So as you can see, each each of each segment of the Vienna sausage are an equal length. So each section that is being cut, we'll call it RS. Well, R short. R is resistance. R R st- R as in Romeo stands for resistance. So we'll call each of these segments R short. So yeah, and then we'll call the whole Vienna sausage R long. And then N is the subdivisions of each Vienna sausage. So essentially R short is equal to R long divided by N. So so the resistance of each segment is equal to the whole Vienna sausage divided by how many pieces the Vienna sausage was cut into. So yeah, and now and now for and now for hit number two, that's just resistors in parallel. There's an equation for resistance and the total resistance. So the reciprocal of the total resistance, or 1 over R's and Romeo total, is equal to the summation of of 1 over all the resistances. So so basically, it's just 1 plus R1, 1 plus R2, 1 plus R3, 1 plus R4, etc., etc., etc. So anyway, but then the thing is, R1 is equal to R2, and so is it equal to R3 as well, and then up to R however many there are. So yeah. Anyways, this whole summation is just 1 over R type R1 divided by N. So R1 divided by N is also just R short. Anyways, it would just look like this. So 1 over R total is equal to 1 over R1 divided by N. So I mean we can just put the N on top since it's the denominator. Since the denominator of the denominator is also the numerator, so basically 1 over RT is equal to N divided by R, and this is R short, by the way. So multiply both sides by R short over N, and multiply both sides by RT, or just get the reciprocal of the two, if that makes it easier for your brain. And then and then you and then you got your answer for the second hit. So the R total is equal to R short over N. So so now to finally finish this whole thing, uh, we are now looking for the resistance of all of this in series. All of these Vienna sausages cut into series, and there you go. The fight. So we are given that R short from hint one is equal to the resistance long divided by the amount of subdivisions of the Vienna sausage, and then uh, and then the total. and that the total resistance of the Vienna sausage in parallel is equal to the resistance of each piece of the Vienna sausage divided by however many pieces of the Vienna sausage you cut into, so or RS over N. So we are given that RS is equal to R long over N. So we can plug in we plug in R long over N for R short. So it's divided by N. So as you can see, n in this case is the numerator of the denominator. So it's essentially also the denominator. So as you can see, n times n in this case is equal to n squared. So your total resistance should equal r, r long divided by n, or the resistance of the whole Vienna sausage divided by the amount of pieces the Vienna sausage was cut into. Well, well anyways, that's your answer for the whole thing. And and if you like this video, please drop a dislike. And I'm sorry for wasting your time talking about Vienna sausages and current and resistance. Well, anyways, see you in the next physics explainer. Sorry for wasting your time.